In this video, we're going to look at classifying stationary points. Now, the second year content includes the Hessian matrix to classify stationary points. However, you're not required to know this for AS. However, what you might have to do is rule out the prospect that a stationary point is a maximum and rule out that it's a minimum, so you can conclude that it must be a saddle point. In order to do this, we're going to refer to some of our definitions of our stationary points. So if it's a maximum point, then what must happen is Z should decrease close to the point in all directions. So if we can find one direction where Z increases and the other direction where Z decreases, we can be sure it's not a maximum. Okay, and similar for minimum, okay, Z should increase in all directions close to the point. So if we can find a direction where it increases and a direction where it decreases, then it can't be a minimum. Now, we can't use this method to classify for a maximum or for a minimum because we can't test every single direction. However, if we can show one direction it decreases, the other one it increases, then we can be sure that this point must be a saddle point and therefore not a maximum or a minimum. So let's have a look at this question here. So we're going to determine whether the stationary point of this surface here is neither a maximum nor minimum. And we're given the stationary point here. It's at 425. Okay, so what I'm going to do is we're going to make use of this point. And specifically, let's start with the x-coordinate. What we're going to do is we're going to change the x-coordinate a little bit. We're going to increase it a little bit and we're going to decrease it a little bit and see what happens. Okay, so let's make x equal to 4.1. So we've increased it by 0.1, just a small margin. You can go smaller than that if you want. And then for y, we're going to keep it fixed at 2. Okay, what we're going to investigate is what happens to the z coordinate. We know at the stationary point it's 5, okay, but what happens when we slightly change the x coordinate? So let's substitute these two values into the original surface equation. So we're going to get z is equal to, and we got 4.1 squared, subtract 4 lots of 4.1 times 2, subtract 2 squared, plus 20 times 2, subtract 15. Okay, we're going to see what does this come out as, so we're going to put it into the calculator. Again, it comes out as 5.01. Okay, so in this direction where I made this little change to the x-coordinate, the z-coordinate has increased. Okay, so because the z-coordinate has increased, we can already rule out that this is a maximum point. Okay, maximum point is no longer possible. Our only options left are our minimum or our saddle point. Okay, so what we're going to do now is we're going to change x again. But this time, I'm going to decrease it. So we're going to get 3.9. And then we're going to keep y as 2. So we're now going to do a similar substitution to before. We're going to substitute those values into the surface equation. So we'd have 3.9 squared, subtract 4 lots of 3.9 times 2, subtract 2 squared, plus 20 multiplied by 2, subtract 15. And I'm going to pop that in the calculator. And once again, I get 5.01. Okay, so that hasn't really told me anything new yet. Okay, all I know is that when I change the x-coordinate a little bit, okay, the z-coordinate is always increasing. So let's investigate our y-coordinate instead. Let's change that. So this time I'm going to keep x as the original value, which was 4. But let's now substitute a different value for y. Let's increase it a little bit. Let's go with 2.1. So then we're going to substitute into our surface equation. So we're going to get z is equal to 4 squared, subtract 4 times 4 times 2.1, subtract 2.1 squared, plus 20 times 2.1, subtract 15. And then we're going to pop that into the calculator. And this time we get 4.99. So if we change the y coordinate a little bit, and in this case we increase the y coordinate, the z coordinate has now decreased. Okay, therefore, because the z coordinate is decreasing, we can rule out a minimum point. Therefore, the only option left is our saddle point. Okay, so we can now make a conclusion. When we change the x coordinate, the z coordinate increased. However, when we changed the y coordinate, the z coordinate decreased. Therefore, 4 to 5, which is the point, the stationary point we were looking at, cannot be a maximum or minimum point.